Hello guys, I am Engineer Mohammed Adnan Khan and you are watching my YouTube channel Being Engineer. This is the part 8 of our video series Moment of Inertia, and in this video we are going to calculate the moment of inertia of a circle by using theorem of parallel axis. We will find moment of inertia of a circle in two different cases, that is case number 1. In case number 1 the reference axis is attached to the circle, whereas in second case the reference axis, that is x-axis, is few centimeters apart from the circle and the y vertical axis passes through the centroid of a circle. Guys, if you don't know what is moment of inertia and what is theorem of parallel axis, you need to watch the previous parts of this series. So let's start our today's topic. Case number 1, as I have told you before, that the reference axes are attached to the circle. Now look at the centroid of a circle, that is center of a circle. Now the centroidal distance from x-axis, that is the distance from x-axis up to the center of a circle, which is represented by distance k, which is radius of gyration, which I have also discussed in the previous parts. So k is equal to radius, that is half of the diameter, and this distance is equal to 2 centimeters. Now centroidal distance from y-axis, that is this distance from y-axis up to the center of a circle, which is represented by r, and it is again equal to half of the diameter, and it is equal to 2 centimeters. The other thing we need to calculate is the area of a circle, which is equal to pi r square or pi d square divided by 4. By putting the values, that is 3.142 multiplied by 4, 4 is the diameter of a circle, divided by 4, we will get the value of area of a circle, which is 12.568 centimeter square. So by now using the theorem of parallel axis, which says that Ixs is equal to Igx plus ak square. Igx is the moment of inertia about centroidal axis, and plus ak square is the area of the circle, and k is this distance, that is radius of gyration. So by putting the values, Igx is equal to pi d4 divided by 64. Now this is the predefined value which will you have to remember these values, which I have also discussed in the previous parts. So by putting the values, 3.14 is for pi, the value of d is 4, plus the value of a is the area of the circle, which we have calculated in the previous slide, and k is equal to 2 and its square. So the moment of inertia about x-axis is equal to 62.84 centimeter power 4. So now to calculate moment of inertia about y-axis. In the previous slide we calculated moment of inertia about x-axis, and here we will calculate the moment of inertia about y-axis. It is equal to Igy plus ar square. Now Igx has been replaced by Igy and k has been replaced by r. So by putting the values, its value is same as the distance of center from both axes is same, so the value of Igy remains the same. By putting the values, we will get the value of Iyy, that is moment of inertia about y-axis for this case number 1, which is 62.84 centimeter power 4. Now proceeding to case number 2, in which vertical axis is passes through the centroid of a circle and x-axis is few centimeters apart from the circle. Diameter is same, that is 4 centimeter. So the centroid, that is center of a circle, lies in the center of a circle. Now to calculate the centroidal distance from x-axis, that is distance of center of a circle from x-axis, which is equal to k, and k is equal to this 3 plus radius of a circle, that is d divided by 2. Sorry, it is d divided by 2, which comes out to be 3 plus diameter divided by 2, and it is equal to 5 centimeters. That is this 3 centimeters plus the radius of a circle, which is 5 centimeters. So now centroidal distance from x-axis, which I have told you is represented by r, so r is equal to 0 centimeters, is this y-axis is passes through the center of a circle, so the distance r will be equal to 0 centimeters. Now area of a circle is equal to pi d square divided by 4. The similar procedure will be adopted to calculate the area of a circle, which is 12.568 centimeter square. So by using the parallel axis theorem, we will use these two formulas, that is moment of inertia about x-axis and moment of inertia about y-axis. Igx is equal to pi d4 divided by 64 plus ak square. We already know all these three values, that is value of d, value of area of a circle, and distance k. By putting all these values, we will get moment of inertia about x-axis for this case number 2. So now to calculate Iyy, that is moment of inertia about y-axis, it will be equal to Igy plus ak square. It is ar square, that is k has been replaced by r for Iyy, and the value of r is 0, as the y-axis is passes through the center of a circle. The value of r will become 0. So the moment of inertia about y-axis will be equal to 12.568 centimeters. I hope you have understand the topic, how to find the moment of inertia of a circle by using parallel axis theorem for two different cases. For more videos, you are requested to please subscribe the channel and press the bell icon to get video updates.